In this video, I'm going to explain how to draw the graph of the functions. Especially, I'm going to explain linear functions and quadratic functions, because we are going to study about the piecewise function, absolute value functions, and or special functions is a general name. And for this subject, we need the graph of the functions and how to draw the graph of the functions. For the linear functions, if you remember, we know the graph is named as line, and the line is y is equal to, we have fx is equal to ax plus b form we have, or y is equal to ax plus b form also it can be. Here a is at the same time also m, which means also slope. You remember this information from the first grade. If you remember from the previous subject, also in while we were solving exercises about the even odd functions, I explained the m is also slope, and when it is greater than 0, it should be increasing graph. When it should be less than 0, it should be decreasing graph. I explained in that exercise part. Okay, the second one is parabola. General form of the parabola, second form is quadratic function, and the graph of the quadratic function is parabola. Y is equal to fx is equal to ax squared plus bx plus c form, and when it is passing through the center of the circle, this is generally ax squared form. And if a is positive, it looks up. If a is negative, it looks down. I'm going to explain this one also. So the name of the graph here, I repeat again, and you know this one from the quadratics. This name is parabola is going to be. Now I'm going to remind you about drawing the graph, linear graph. How to draw the linear graph? Linear graph, y is equal to 2x minus 4 is going to be. Y is equal to 2x minus 4 graph. How to draw this one? For finding the linear graphs, for drawing the linear graphs, we have to find 2 points on the line. So you can choose your points, x point, any variable, because for the linear functions, the domain is also all real numbers, it says. So you can choose any number that you like for the x. So you can choose 0 and 1 and 2. These points are easy points to show on the graph. That's why you can choose this one. But generally, I'm going to choose the x is equal to 0, x is equal to 0, and this gives y-intercept of the function, and x is equal to 0 gives us y-intercept, y is equal to 0 gives us x-intercept of the function. So when you say x is equal to 0, you are finding y-intercept. I'm writing in the equation 0 for the x. Y is equal to 2 times 0 minus 4. Y is equal to, this 2 times 0 is equal to, y is equal to minus 4 it's going to be, because 2 times 0 is equal to 0. When y is equal to minus 4, it means that our line is going to pass through y is equal to minus 4. Sorry, the y is equal to minus 4 point. On the y-axis, minus 4 value is going to be here, this point. So y is equal to minus 4 means x is equal to 0, y is equal to x is equal to 0, y is equal to minus 4. This is the first value. What about the second value? Y is equal to 0. So y is equal to 0 means 0 is equal to, I'm replacing in this function, 2 times x minus 4. So 2x is equal to 4 is going to be, x is equal to 4 over 2, and x is equal to 2. The coordinates of the point is 2 and 0 is going to be 2 and 0 is this point, and it's going to be equal to y is equal to, the coordinate is 2 and 0 is going to be, if I draw the graph, it's going to line. First, we know that one because this is linear function. That's why a line passing through these points it's going to be. Okay, then I'm drawing a line passing through these points. Then is going to be here. It's going to pass through from these points also. Then these points and these points like this. Yes. This is the graph of our function is going to be. Okay, here let's draw the arrows also. Okay, then the name of the graph is y is equal to 2x minus 4 is going to be, or fx is equal to 2x minus 4. Sorry. Fx is equal to 2x minus 4 is going to be. Now we are going to draw the quadratic graph. The basic form of the quadratic graph is going to be for us y is equal to x squared is our basic graph. For the quadratics, so 1x squared, actually the coefficient is 1 here, and I'm going to draw the graph of the quadratic function. As I said, we need to find the values on the function, and we know the general graph of the function. Then we are going to connect these points. Now y is equal to x values and y values there are going to be, and I'm going to choose some x values and I'm going to find some y values for these x values. I'm going to choose x is equal to minus 2, x is equal to minus 1, x is equal to 0, x is equal to 1, and x is equal to 2. I'm going to mention one more time this one. I'm choosing these values. Random values, they are not random values actually. Randomly you can choose the values, but these are closer points to coordinate axis, intersection of the axis. Here x is equal to minus 1, x is equal to minus 2, x is equal to 0, x is equal to 1, and x is equal to 2 points. And with respect to these points, I'm going to find the y value. What about the y? Y is equal to x squared. So this is going to be minus 2 squared, which is equal to 4. So the first coordinate is equal to x is equal to minus 2, y is equal to 4. So the coordinate x is equal to minus 2, y is equal to 4. This point is the first coordinate it's going to be. So minus 2, 4 place is going to be here. The second coordinate minus 1. Minus 1 squared, y is equal to minus 1 squared. Minus 1 squared, that's equal to 1. So the y value is 1 here. And x is equal to minus 1, y is equal to 1. X is equal to minus 1, y is equal to 1 here. So the second point is going to be here. Then the coordinate is minus 1 and 1 is going to be here. The third point is 0. So 0 squared is equal to, we know that it's equal to 0. The coordinate is 0, 0. This is also the intercept of the x-axis and y-axis. X-intercept and y-intercept, sorry, I wanted to say. Because the function is passing through the origin, which means x-intercept and y-intercept is 0 and 0 together. Okay, now we will continue with the fourth value. Fourth value, x is equal to 1, y is equal to x squared, 1 squared, so it's equal to 1. Then the x is equal to 1, y is equal to 1 is the coordinate 1, 1. Here it's this point, and this is equal to 1, 1 again. And the last point is going to be here, this point, because the parabolic function with respect to its vertex, it's going to be symmetric, which means on this side, if I choose this 2 point, or if I find this 2 point, on the other side, this 2 point and this point, it must be, let's see, that's 2, and the value, it's going to be equal to 2 squared, which is equal to 4. As you see, the coordinate is 2 and 4, which I noticed before. Okay, then here I'm going to draw the graph of it. I know the figure, that's important. I know the figure, parabola. Then parabola must pass through these points. So I know the figure, that's why I'm going to draw the figure with respect to parabola figure. Is going to be, sorry for 2 times, and then it's going to come here, then it's going to make vertex here, then here, and it's going to continue till infinity. Maybe it should be a bit left, but you can correct that one later. Here it can be a bit like this also. I'm going to explain on this page shifting the quadratic graph. If you remember from the previous page, I draw the y is equal to x squared line, y is equal to x squared line, and this is y is equal to x squared line. If I transform this one on the y-axis, how it's going to affect the function, and if I transform on the y-axis, how it is going to affect the function. I'm going to explain here that part. Okay, now I'm going to use the same function, y is equal to x squared. If I move this function, I'm going to copy the same function, this function. If I move this function k unit up, the new function is going to be, I'm going to choose different color for this one. This new function is going to be, this is also, as you understand from the grids, this is 1, 2, and 3. 3 unit up, I took the graph. That's why this is y squared. Pardon. This is y is equal to x squared plus k is going to be, k is equal to 3 here, so x squared plus 3 is going to be. If I move the same graph, 3 unit down, it will be x squared, minus k, or here, let me choose this one for the second graph. As you see, the center of the parabola moved 4 unit down, and I'm going to choose different color for that one. Then this is going to be equal to y is equal to x squared minus 4. Here I'm going to move the graph on the x-axis. What is the form for the moving on x-axis? The same graph, I'm going to copy the same graph, and I'm going to move 2 units left. When I move the same graph, y is equal to x squared graph, moved to 2 units left, then the function is going to addition and subtraction here inside the square unit it's going to be, and the graph of, pardon, let me change the color firstly of this one. Then the graph of the function is going to be y is equal to x minus a square, or b square it's going to be, that b here, minus 2, so this is going to be x plus 2 square, it must be. How to understand that one plus 2 or minus 2? When you put the vertex point in the function, it should give you 0, like this one. This is 0, 0, vertex point here it is, and it's 0 square. So when you put here the vertex point minus 2 plus 2 square, it should be 0. That's why when it is minus 2, this sign must be plus. When it is plus 2, let me show also that one. plus 2 or another value can be. Let me duplicate this one and maybe move 3 units to right, and I'm going to change the color of the function. Let's make it here blue, dark blue maybe, and here it's going to be y is equal to, this is y is equal to x minus 3 square. It must be because the vertex on the 3. This shifting is same for also the negative x square. I mean, here the graph of the function is y is equal to x square. There is no problem about that one. If it is minus x square, only, I'm going to duplicate this one, only the graph rotates down and it looks down. This is concave down also it's called, and the graph is going to be in this form. This is y is equal to, this is y is equal to x square graph, minus x square graph, sorry, and here every operation that you are going to do, I mean the shifting for on the y-axis, shifting on the x-axis is going to affect same way the y is equal to minus x square graph. Only you have to be careful, if the parabola looks down function, it should be negative. The other shifting part is same.